Crash Course Instrumentation, Episode 28, Soldering Basics. Welcome to Crash Course Instrumentation. In today's episode, we're diving into one of the most fundamental hands-on skills in electronics and control work, soldering. Whether you're repairing a loop, building a prototype, or assembling a sensor panel, chances are you're going to need to solder. So what is soldering? Soldering is the process of joining metal conductors using a filler alloy, commonly referred to as solder, that melts at a lower temperature than the base metals. It's not welding. It's not brazing. Only the solder itself melts, not the parts you're joining. When done right, soldering provides a secure mechanical connection and a low-resistance electrical path. The role of good soldering depends on heat. But here's the catch. It's not about heating the solder. It's about heating the work. That means your soldering iron tip must transfer enough heat to the joint so that when you apply solder, it flows and wets both surfaces. Wetting is when molten solder spreads smoothly across the metal surface instead of beating up. If you don't get wetting, you won't get bonding. Poor wetting leads to cold solder joints, which are brittle, resistive, and unreliable. Enter flux. Flux is a chemical cleaner that removes oxidation and impurities from the metal surfaces as they heat up. Many solder wires have a core filled with rosin-based flux. When heated, the flux cleans the surface and helps the solder bond. Without flux, solder often won't wet or bond well. Safety first. Soldering can expose you to molten metal, heated tools, and toxic fumes. Always use eye protection, ensure good ventilation, or better yet, a fume extractor. Never hold solder in your mouth, and always wash your hands after working, especially if you're using leaded solder. Tools of the trade, soldering irons come in many shapes and sizes. For general electronics work, use a pencil-style iron rated around 25 to 75 watts. Use chisel or conical tips depending on your task. Keep your tip clean and tinned. Oxidation reduces heat transfer. Use brass wool or a damp sponge to clean the tip. Avoid using abrasive materials that wear down the plating. And yes, tip maintenance matters. A clean, shiny tip means better heat delivery and better joints. Types of solder. Historically, solder was made from a tin-lead alloy, typically 60-40. Today, most solder is lead-free, made from tin, silver, and copper. Lead-free solder requires higher temperatures and degrades iron tips faster, but it's safer for the environment and legally required in many industries. Soldering in the field. In instrumentation work, you'll often solder wire pigtails, terminal lugs, PCB repairs, or small connectors. It's critical to form a mechanical bond first, like twisting wires or looping a lug, then apply solder to reinforce it. Solder should never be the only thing holding a connection together. Quick tip, always apply heat to the component, not the solder. Then feed the solder into the joint. Let it flow and form a concave, shiny bead. Common mistakes to avoid. Applying solder directly to the iron, not the work. Moving the joint before it cools, causes fractures. Using dirty or oxidized surfaces. Skipping flux or working too cold. In industrial settings, you'll also see reflow ovens and wave soldering machines. These are used for mass production, where thousands of connections are made using precise temperature profiles. Surface mount devices, SMDs, are soldered using paste and heat, not by hand. Coming up in this soldering series, we'll look at soldering metallurgy, desoldering techniques, how to spot bad joints, automated rework, and PCB design tips that improve solderability. But it all starts here, with heat, flux, clean surfaces, and good technique. If you learned something today, give us a like and subscribe for more weekly episodes on real-world electrical instrumentation. And check out our full video library at youtube.com/Crash Course Instrumentation. Special thanks to Tony Kuphaldt and the open source community behind the Model project. This episode is based on his work, available for free at ebiblio.org.